Mm-hmm.
Yeah. So when we have sine of x multiplied by cosine of x and they are both raised to some exponent, then we look at the nature of those exponents. So if exponent of sine is odd, then we make the substitution cosine of x equals u and vice versa. And if both the exponents are odd, then we can make either of these substitution. And if both a and b are even, I think I gave you a problem which is of type 4. If both a and b are even, then we will use the half angle trigonometric identities. Now, the thing is, sometimes in homework, I might give you problems problems of those type which we haven't discussed in the class yet, because the reason is I love to see how you would approach something which we haven't done in class. Just I'd like to see that how you would tackle such a problem, because it can also happen in your school exam or your test that you get a problem which hasn't been discussed in the class. So, but don't worry about it. We will do all types of integrals that you can possibly see in your exam.
Sounds great.
Okay, so I'm gonna start this one here, and we will do a problem. Today we will be doing 3 types. Okay. So let's say that we have example number 1. Let's say that we have sine raised to exponent 3, and this is multiplied by cosine raised to exponent 5 dx.
Mm-hmm.
So here, exponents of both. Yes.
Could you expand and like zoom it in?
Yeah.
Thank you.
Let me write this properly. So this is
We look like we have both odd functions.
Yes, both of the exponents are odd.
Interesting. Remember you telling me the rule that if the power of the sine is odd, then you substitute cosine as u.
No, the thing is, here both exponents are odd. So this is third case. Here, if both a and b are odd, then you can substitute either of them as u. So,
okay.
Yeah, here our life is so much easier. So let's substitute cosine of x as u. Okay, so we have negative sine x dx equals to du. So that means that dx is equal to du over negative sine x.
So then dx equals du over minus sine x.
Yes, dx equals du over negative sine x. Now let's put everything back into the integral. So we have sine cube x
times u to the fifth times du over minus sine x.
Yes.
dx.
So I'm gonna take the negative sign outside of the integral and we get sine x. Okay?
Right. And wouldn't the sine x cancel, and that would be sine squared x times u to the fifth?
Exactly. So this gets cancelled and this becomes 2. So we get negative sine square x times u to the power 5 du. And now we can easily convert sine square x into u in terms of, I can write it in terms of cosine. So sine square x can be written as 1 minus cosine square x.
Squared x. times u to the fifth du.
And this is 1 minus cosine, we have substituted as u, so 1 minus u squared times u to the power 5 du. And now it's very easy to solve. So let's distribute u to the power 5 inside. So we get
this would u to the fifth minus u to the
7. Okay, so I'm going to distribute this negative sign as well. So this becomes negative and this becomes positive.
So won't it be negative u to the fifth plus u to the seventh?
Yes, exactly. And then when we integrate it, this becomes negative u to the power 6 over 6 plus u
plus to the power of 8 over 8. Then we substitute back the cosine. That's going to be negative cosine 6 to x over 6 plus cosine to the 8th x over 8 plus c.
And that's our answer.
Fun. I want to do another one. I'm sorry, this is kind of satisfying to solve it and getting the right answer.
Yeah, let's do one more.